Okay, so this is a 2014 external exam and question 3. You can pause and read the question so you understand it. Two people are playing a game, two fair six-sided dice, throw them, add them together. Here's the probability distribution table showing all the possible sums you can get and the probability of that happening. Remember, a sum of 2 can only come from throwing 2 1s, and the sum of 12 from throwing 2 6s. Something like a sum of 7 though, you can get that from throwing a 3 and a 4, 4 and a 3, 5 and a 2, 2 and a 5, 6 and a 1, 1 and a 6. There's a lot more ways that that sum of 7 can come up, so you can see why it's a higher probability of that happening. Right, what's the probability that Matthew loses on the first roll? So the probability he loses is if a 2, 3 or 12 comes up, and we're going to assume that that means that M wins, Fitu. If M loses, then W must win. Probability of a 2 or 3 or 12 coming up, not very likely. Probability of a 2, sum of 2 is 1 over 36. Sum of 3 and a sum of 12. Now the words we use are or, and in statistics when you say or, that means to add. And I get 4 over 36, which is 1/9. Right, the probability there is no winner. So we'll have to assume that 7 or 11 M wins, 2, 3, 12 W wins, and anything else there is no winner. So the possibilities for no winner would be if it was a 4 or 5 or 6 or 8, 9 or 10. Just check. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, so when we say or, that means to add. So I'm adding together the probability of a 4, a sum of 4, sum of 5, sum of 6, sum of 8, 9, 10. And altogether that adds up to 2/3. So probability there is no winner on the first roll is 2/3. Right, and then the game gets on and it gets more complicated. So you can pause once again, read the question, see if you can work it out, maybe try drawing a tree or thinking about what's happening here. I'll try a tree. So M wins, which was if it was 2, 3 or 12. Fitu wins. Oh no, that was 2, 3, 12. Matthew wins if it's a 7 or 11. And neither of them win the question we've just answered, which was 4, 5, 6, 8, 9, 10. Matthew keeps rolling the dice until either the sum on the dice is his target score or he rolls a sum of 7. So Matthew keeps rolling. This is if it's a neither. And then he can either win, or Fitu does, or it will be a neither. Matthew wins if the target number comes up, so he rolls a 5 on the first roll, which brings them down this branch, and that becomes his target number, and he wins if he rolls a 5 next time. If it's a 7, then Fitu wins. So the probability of him rolling a 5 the next time, if you look at the table on the previous page, probability of getting a 5, a sum of 5 is 4 out of 36, which is 1/9 again. Right, probability Matthew will win the game on the third roll. So if we go back to our tree, 7 or 11 M wins, 2, 3, 12 Fitu wins, 4, 5, 6, 8, 9, 10 neither. Right, and they're going to the third roll, so this must have happened. Once again, M, W, neither. Now we know that this one was a 5, which becomes his target number, and he wins if he rolls a 5. If it's a 7, he rolls a 7, then Whetū wins. So anything else, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, they roll a third time. We want to find the probability of Matthew winning on that third time, which would mean he's rolled the 5. The probability of him rolling a 5 is 4 out of 36. So the probability that he wins, that's beside the wrong one, probability that this happens, given that they got a 5 the first time, means you've come down the neither branch and then that one. Now the probability of all of this happening, you need to go back to the previous page, add up all of those probabilities together, and it should come to 26 out of 36. We need to multiply down the branch, so it's this branch times the 4 over 36, which comes to 0.0802469, and we could do some rounding on that, 0.082dp, just check it's not a percentage they want, probability, so that's fine. Right, one to go. Changing the game slightly. Want to modify it to be fair. Finish after a maximum of 2 rolls. 2, 3 or 12, so we know that that's 4 out of 36. 7 or 11, you can go back and check by adding up the probabilities, and this one will be 24 out of 36, so we've got those from the previous page. We want to come up with an event, perhaps, so that has this probability, and this will be 1 minus p, because coming from the same branch, these two probabilities have to add to 1. So whatever probability we find for Matthew to win, Whetū will be 1 minus. Now we want the probability of them winning to be exactly a half. So we want the probability that M wins to equal a half, and we want that to be the same as the probability Whetū wins, so that the game is fair. And they both have a 50% chance of winning. So the probability of M winning, M could win this way with 8 over 36, plus he could win with this branch here, M, which is 24 over 36 times P. Right, now Whetū, probability of him winning, the top branch, 4 out of 36, or he could win this branch, multiplying down the branch, we get 24 over 36 times 1 minus p, and those two things we want to be equal. Or to in fact both equal a half. Yes, so if we both want them both to equal a half, the top equation looks easier to solve. So I want to solve 8 over 36 plus 24 over 36 times p equals a half. Now you can do this in Solver, as long as on the next line you write p equals and get the correct fraction. The answer is 5/12, so that would be appropriate. For some working, we're going to subtract the 8 over 36, and then we would divide by the 24 over 36, next step. Using brackets, definitely, around the fractions, and we come up with an answer of p equals 5/12.